This is exercise 11.3, question 27, and the question says that a circle has centre -1, 3 and radius 5 units. Now I've done a quick sketch here that I know it's not drawn very well to scale, but the centre of the circle is -1, 3, radius 5 units. It really has not been drawn accurately, okay? The first thing is to find the equation of the circle. Now you can try that. That's fairly straightforward. I'll pause the video so you can attempt it and then I'll just show the working. Okay, so I've just shown there the equation of the circle. That's just straightforward, substituting in the centre of the circle and the radius. So the equation is x plus 1 squared equals y minus 3 squared equals, plus y minus 3 squared equals 25. Now for part B, it said that the line meets the circle. So this line here, I've done a quick sketch of that line as well, just showing the y-intercept is 1 there, and gradient roughly 3, that this line meets the circle at 2 points. Find the intersection of the 2 points. You've basically got two equations, the equation of the circle and the equation of the line. You need to solve those simultaneously to find the coordinates of the points of these 2 points where the line meets the circle. So you can do that now and then restart the video when you're done to check your answer. Point of intersection of the line and the circle, we will solve the equation of the circle and the equation of the line simultaneously. Here I've got the equation of the circle, this is the equation of the line. You can solve this by substitution, so if we make y the subject of the formula here, y equals 3x plus 1, we can substitute this into this y up here. So substituting equation 2 into equation 1, we would get that there, replacing the y with 3x plus 1. So 3x plus 1 minus 3 is the same as 3x minus 2 squared. You now need to expand all of this and solve for x. Once you've solved for x here, you can substitute the value of x in here and solve for y. Pause the video and attempt the question, and I'll turn the video back on when I'm done. So expanding this, it's a perfect square. We get x squared plus 2 times x times 1, which is plus 2x plus 1. Expanding this perfect square, we've got 3x all squared, which is 9x squared. Then we go minus 2 times 3x times 2, which is minus 12x plus 4 equals 25. Collecting like terms here on the left, we've got 10x squared minus 10x. We've got plus 5, but we take this over the other side and we've got minus 20. Now these can all be divided by 10, so you will get x squared. So we're going to divide through by 10. We get x squared minus x minus 2 equals 0. This is easily factorized to be x minus 2 bracket x plus 1 equals 0. And that's correct. And therefore we get that x equals 2 or that x equals -1. Okay, obviously diagram's not drawn to scale. Now when, let's substitute these. So when x is 2, I'm just going to work out the y value. The y value will be 3 times 2 plus 1, which is 7. So when the first point of intersection is 2, 7, in other words, this point here, point x will be 2, 7 in the diagram up there. And this point here, when x is -1, we get 3 times -1 plus 1, substituting that into equation 2. So we're subbing those in equation 2. We get -3 plus 1 is -2. So the second point of intersection is -1, 2. So this point down here is -1, -2. Okay, now that's part B. So the question was find the coordinates of the points of intersection, which we've just done. Then it says let the coordinates be x and y, where y is the coordinate directly below centre C. Now we know that one of the points of intersection was -1, -2, so that's point C. Sorry, that's below point C, the centre, so that's point Y. The other point of intersection is 2, 7. It then says find the coordinates of point Z where xy, so where xy is a diameter of the circle. Now a diameter passes through the centre of the circle. So Z will be a diameter, xz is a diameter, and diameters pass through the centre of the circle. We have to now find the coordinates of point Z. Okay, where I think we mean to say where xz is the diameter of the circle. Now if C is the centre of the circle and xz is a diameter, then the distance from C to x is the same as the distance from C to z. In other words, C will be the midpoint of xz. So I'm going to write that C is the midpoint of the diameter xz. Okay, so obviously you'll use midpoint formula. Now you have the answer for the midpoint. I'm going to let z have coordinates x, y. So we know that -1 is the midpoint of 2 and x, and that 3 is the midpoint of 7 and y. So we'll set that up. So the way we would set up, remember the formula for midpoint is x1 plus x2 over 2, comma. So it's the average of the x values and the average of the y values. That's how you find the midpoint. So looking at the x value, we know that -1 is the average of the 2 and the x here. And solving that, we get -2 is 2 plus x, and so x equals -2 minus 2, which is 4. Looking at the y values, we know that 3 is the average of 7 and the y values, so we get that 3 equals y plus 7 over 2. Solving this, we get 6 equals y plus 7, therefore y will be -1. So therefore, the coordinates of z are 4 and -1. Actually, -4. X here is -4. So the coordinates of z are x is -4, comma, y is -1. So just fix that, okay? I'll just move this down here. Okay, z is the point, therefore -4. So I'll just put that z is -4, -1. Now the last part of the question, part D, says hence show that angle z, it says zxy. I'm just going to have a look at that. I think the question's written down incorrectly. I believe that the remainder of the question should be that show that angle xyz. I'd say that you've got the right angle here because the angle in a semicircle is a right angle. So we want to show that the angle xyz, sorry, this is not written correctly, so that the angle xyz is 90 degrees, because remember that the angle in a semicircle is a right angle. So the way that we show that we've got a right angle here is that we look at the gradients of the lines. So if angle xyz is a right angle, then the gradient of xy, we need to look at the gradient of xy times the gradient of yz. So sorry, I'm just off screen there, so I'll just lift that up a bit. So let's look at the gradient of xy first. Now we know the coordinates of x and y, they are 2, 7 and -1, -2. So gradient of xy, I'll just put it under here. So actually I'll just write the coordinates up here. So x is the point 2, 7, y is the point -1, -2, and z is the point -4, -1. So we're going to look at the gradient of xy up here. So gradient of xy is y2 minus, so we know that the gradient formula is y2 minus 1, y1 over x2 minus x1. Let's look at the gradient of xy. It'll be 7 minus -2 over 2 minus -1. And then we're multiplying that by the gradient of yz, and that gradient will be -1, sorry, it'll be -2 minus -1 over -1 minus -4. Now that's equal to 7 plus 2, which is 9, over 2 plus 1 is 3. So it's 9 over 3, which is 3. The gradient of this is -2 plus 1, which is -1, over -1 plus 4 is +3. Now, looking at those, 3 times -1/3 is -1. So therefore, the gradient of xy times the gradient of yz is -1. So therefore, xy is perpendicular to yz, and we can now conclude, therefore, angle xyz is 90 degrees. So therefore, angle xyz, sorry, I've just run out of space, is equal to 90 degrees. Okay, and that's the end of that question. Sorry, I've just run out of space there, but you should be able to see all that working there now. Now this is exercise 11.3 question. This is exercise 11.3 question 28. And the question is to find the perpendicular distance from the point P, which is 2, -5, to the line 5x plus 12y minus 2 equals 0. And then you have to find the equation of the circle with center P and tangent 5x plus 12y minus 2 equals 0. Now, if you want to get an idea of what's happening, we could do a quick sketch. We've got the point P, which is 2, -5. That might be somewhere down here. And you want the distance from that point to the line 5x plus 12y minus 2 equals 0. To quickly sketch that line, I can find the y-intercept. To find y-intercept, put x equals 0. And if x is 0, y will be, I think, 1/6 is what I get. If x is 0, we cover this. Y will be, take the 2 to the other side. We get y is 2 on 12, which is 1/6. So that's roughly there. And when when y is 0, we get that x is 2 on 5. Now these are very small values, 2/5. So it looks like the line roughly looks like this. Okay, that looks like what the line is. Hopefully I've done that correctly. Actually, I think I've done it the wrong way around. Y-intercept was 1/6 and this one is 2/5. Anyway, look, they're both positive. And both those values are very close to the origin. So sorry about that, just fix that up. But that's how the line looks. I mean, if we look at the line, if we make y the subject of the formula, the other way to look at it is make y the subject, and we'll get 12y is minus 5x on 2, or y is minus 12 on 5 minus 2 on 5, sorry, plus 2 on 5. So it's got a negative gradient and it's really close to the origin there. So what we're doing is looking at the perpendicular distance from the point to the line. Okay, so we'll do that. It doesn't look like it's very far away, but you'll obviously use the perpendicular distance formula. So you can do pause the video and work that out now. So remember, we substitute this xy value. Sorry, I'm just going to focus this. We substitute this xy value into the equation there. So it's 5 times 2 plus 12 times -5 minus 2. So the absolute value of all of that over the square root of a squared plus b squared, which is 5 squared plus 12 squared. So that perpendicular distance is 10 minus 60 minus 2. So it's 10 minus 62, which is absolute value of -52 over the square root of 5 squared plus 12 squared. Look, this is a triad, 5, 12, 13. The answer will be square root of 169, which is 13. So therefore, the distance is absolute value of 52, which is 52 over 13, and that distance is 4 units. Now, obviously, this is not drawn to scale very well. So that's 4 units from there to there. It doesn't really look like it. But then this diagram's not drawn very well. So that's the perpendicular distance from this point to -5 to the line. Hence, find the equation of the circle with center P and tangent that. In other words, if you have a look at what you're trying to find, if you want the center P and this is a tangent, if this line is a tangent, then it only touches the circle at one place. In other words, if this is a tangent, so if the line is a tangent, then if that is a tangent to your circle, then D, the distance, which is 4, is actually equal to the radius of your circle, which is equal to 4. And now, therefore, they're just asking you to find the equation of the circle. So what you want is the circle with center to -5 and radius equal to 4. So that's all that they're asking you to find. And you can pause the video and do that. That's straightforward. So that equation will be x minus 2 squared plus y minus -5 squared, which is y plus 5 squared, is equal to 4 squared, which is 16. Okay? And that's the end of that question. I think I've already set homework for you, which was to do a few questions. Could you please also, I want you to do, I think I was asking you to do questions 20 to 28. I think we did question 21 in class, so you need to do, I think I asked you to do a few questions between question 1 and 19, but I want you to do exercise 11.2 question 18 in addition to what I set today. That's an extra question there. And also if you could do, I know I asked you then to do exercise 11.2, I think it was question 20. We've done 21, so you need to do 22 to 26. And I can't remember if 19 was in it. Just see what I wrote down today. Also, can you go back to, sorry, this is exercise 11.3, I mean. That's in exercise 11.3. Could you also do exercise 11.2? We only did up to question 19 yesterday, so I want you to do a few more questions there. Just having a look at the textbook. The extra question I want you to do in exercise 11.3 is question 18. Could you please do that? And I believe in class I've set from 21 to 26 for homework as well, plus there were 1 or 2 or 3 earlier questions before question 18. And please do the following additional exercises in in exercise 11.2. Could you do question 21, 22, 24 and 25? Those follow on from the extra examples that I did in class today. Okay, that's the end of the video. Thank you very much.